Hi, my name is Alexis Garcia. I am a master's degree student in food engineering of Universidad del Valle, Colombia. I made this video like assignment for my class of transport phenomena. I hope you like it. Take a look.
Oh man, this results can't be right. A better production for the bacteria. I'm going to ask to my master students. Maybe they can give me idea.
Hi, Professor Perez.
Hi Judy, how are you?
Are you okay, Mr. Perez? You look tired.
Yes, Judy. It's just the results from the...
Maybe it's time we get to the basics. You know, establishing the material balance.
That is a good idea. These are the conditions we are working in the lab.
Ethanol production by yeast and bacteria. Both Saccharomyces cerevisiae yeast and Z.mobilis bacteria produce ethanol from glucose under anaerobic conditions without external electron acceptors. The biomass yield from glucose is 0.1 grams per gram for yeast and 0.05 grams per gram for Z.mobilis. In both cases, the nitrogen source is ammoniac. Both cell compositions are represented by the formula carbon, hydrogen 1.8, oxygen 0.5, nitrogen 0.2. What is the yield of ethanol from glucose in both cases? How do the yields calculated in A compare with the thermodynamic maximum? It's important to establish what is the reaction, so the anaerobic fermentation equation is presented. The reactants are glucose, carbon source, ammoniac, nitrogen source, and the products are ethanol, alcohol, biomass grow from the microorganism, dioxide carbon, and water. Previously, the problem present what are the biomass yield in terms of mass, so we decide to convert that mass term to mole term. With this step, now we know what are the quantity in terms of moles produced by 1 mole of glucose. So, in the case of Saccharomyces cerevisiae, 1 mole of glucose produce 0.8 moles of Saccharomyces. And for the case of Z.mobilis, 1 mole of glucose produce 0.366 moles of Z.mobilis. Now we are going to find what are the quantity of ethanol produced by the yeast, the Saccharomyces cerevisiae. The first step is establish the balance for each one of the elements present in the reaction. So we are going to create equations for carbon, hydrogen, oxygen, and nitrogen. The second step is to resolve a linear equation system. We have 3 variables B, D, and E, and 3 equations. The steps are presented in the next slides. The results are the coefficients from ammoniac, ethanol, carbon dioxide, and water. Now we know which is the quantity of moles produced of ethanol per mole of glucose. In the case of Saccharomyces cerevisiae is 1.72 moles of ethanol per mole of glucose. Now we are going to find what is the amount of ethanol produced by Z.mobilis. To find this, we are going to follow the same steps for Saccharomyces cerevisiae, establish the elemental balance and resolve the equation system. We find that Professor Perry isn't wrong. The Z.mobilis, the bacteria, produce more moles of ethanol than the yeast. The results are 1.87 moles of ethanol produced by Z.mobilis. For the part B of the problem, we are going to compare the results from Saccharomyces cerevisiae and Z.mobilis with the theoretical of maximum capability of the glucose to produce ethanol. So we know from the classic reaction of fermentation that 1 mole of glucose is capable to produce 2 moles of ethanol. We can see the yeast is capable of producing 86% of the theoretical maximum, meanwhile the bacteria is producing 94% of the theoretical maximum. Is better for the ethanol production.
The lab results were right, Professor. The bacteria is better for alcohol production. The mass balance confirmed this.
Thank you, Judy. Maybe now I can catch some sleep.